Hi, my name is Daniella.
Hi, I'm Hannah.
Today we're going to talk about the concepts of inertia, and we have some really fun demonstrations to show you guys. And the first concept we're going to talk about, like I said, is inertia. And that has to do with Newton's first law. And Isaac Newton was a very smart man, and his first law was that an object at rest will remain at rest unless acted upon by an outside force. And that can be displayed by just this cup. This cup is going to stay at rest forever unless it's acted upon by an outside force, like my hand pulling this piece of paper. And now, the other part of his law is that an object in motion will remain in motion unless acted upon by an outside force. So this is in motion right now, and it would remain in motion unless acted upon by another force. And that force is friction, which stops it. So another demonstration we can show you is, let's get a reference point. Can we grab a marker? We can edit that.
Yeah. Right.
So here we have a reference point, and I'm going to pull this piece of paper out really quickly, and you're going to see that once the paper's gone, this object is going to remain at rest because there's nothing acting upon it. And you can see it moved just a little bit, but it only moved when the piece of paper was under it.
Okay. Newton's second law says that the net force of an object equals the mass times Should I read these? Okay. Newton's second law says that the net force of an object equals its mass times acceleration. I can also demonstrate this with a cup and a piece of paper. Right now, the net force on this cup is 0 because there are no outside forces and it's not accelerating at all. When I do apply an outside force, it will accelerate and start to move. Yes, I should have to go. Okay.
Forces come in pairs. Newton's third law is that forces come in pairs, and that can also be demonstrated with this cup. So the reason that this cup is at rest is because there are two forces acting upon it. There's gravity, which is pushing this cup down, but then there's also the force of the table acting back on the cup. So those two forces cancel each other out, and that is why this cup is at rest. Now we have another really fun experiment, and Hannah's going to show you guys this one.
Okay. Straight in?
Yeah, straight.
So, going back to the concept of inertia, we know that an object at rest will tend to stay at rest unless acted upon by an outside force. So what I'm going to do now is I'm going to act an outside force, but only on the bottom layer of this Jenga tower. So hopefully, only the bottom layer will accelerate and move. The rest of the tower will stay where it is. Inertia.
And I get to do.
Yeah. We can repeat it a lot of times. And now Daniella will demonstrate.
Never done this before.
There we go.